All right. So now that we know how to take the derivative and find the antiderivative and write it in the power series, so we have problems like this where it says express this function 1 divided by 1 minus x, that quantity squared, as a power series by differentiating 1 over 1 minus x. So what they mean by that is you're not going to work with this expression here, although you want to find out what it's equal to as a power series, but you don't want to work with this expression. They're saying take the derivative of this and then use its power series to write this guy. Now, why would they say that? Well, let's see. If I take the derivative of 1 over 1 minus x with respect to x, what does that end up being? If I treat it like this, then what will I have? I will bring down my negative 1, 1 minus x to the negative 2, multiplied by negative 1 because of the chain rule, right? So now, what is this equal to? This is equal to positive 1 over the quantity of 1 minus x being squared. So what they're asking us to do is they said, hey, the derivative of this expression is this expression here. Now we know what this is as a power series, right? So now we know how to take the derivative of a power series. So if I take the derivative of this guy's power series, it should be equivalent to this. Okay? So that is what we're going to do. We're going to go, okay, derivative with respect to x of 1 over 1 minus x is equivalent to, and we're going to write it as a power series, the derivative with respect to x, the sum, n equal to 0 to infinity of x to the n, because that's what this one is equal to, right? And if you want to, you can expand it. Let's just pretend we expand it. It'll be the same as 1 plus x squared plus x cubed, dot, 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 right? So now I want to take the derivative of that entire quantity. Well, I would just be doing the power rule, right? I would bringing down my exponent and then subtracting 1. So that is the same thing I do for this expression. This is the same thing as the sum, n equal to 0 to infinity, of the derivative with respect to x of x to the n. Which is equal to, well, we know what that is. That is n x to the n minus 1, right? But now we're going to have the sum of that. N equal to, now, when I take the derivative of this guy, this is going to be 0. When I take the derivative of this one, this is going to be 1. When I take the derivative of this one is going to be 2x, and so on and so forth. So this one is going to go away, and there's going to be my first term. So if I test out my numbers, if I put 1 in, what's 1 minus 1? 0. And that is going to give me 1 to infinity. And that's my answer. Okay, so we will call this part A. Part B is going to be, what is the interval of convergence? of 1 over 1 minus x being squared, question mark. Well, we'll go, oh, wait a second, I have a theorem for that. Where's my theorem? It's right here. Whatever this radius of convergence is, then its interval of convergence would be this guy, and therefore these ones have the exact same. So we know what this radius of convergence is. We know it's r is equal to 1, right? And we know its interval of convergence is -1 to 1. And so therefore, this one is supposed to be -1 to 1. So here we took the derivative of something that we know its power series. Okay? And so then we found this by doing a power series. Okay, actually, let me add this on. This is equivalent to 1 over 1 minus x being squared. That is what we were trying to find. Okay, so now the next, we did a derivative. Now let's do antiderivative. Okay, this time we're going to do the antiderivative, because if we look at this, we know its derivative is 1 over 1 minus x, but negative, right? The derivative with respect to x of natural log is equal to 1 over 1 minus x, and then take the derivative of that, and that's going to give us -1, right? So we know what the power series is for this part. All we need to do is put a negative in front of that, right? So, negative the integral of 1 over 1 minus x dx is the same thing as natural log of 1 minus x, right? Oh, go back. Plus. So this is going to be, we know what this sum is. This is the sum n equal to 0 to infinity of x to the n dx. I should add plus c. And then we just integrate this. So this would be the integral, lo siento. Take the antiderivatives. So this is going to be negative the sum. And antiderivative this is going to be x to the n plus 1 divided by n plus 1 plus c. And then we need to determine what happens when we expand this. If I took my expansion 1 plus x squared plus x cubed and so on and so forth, and then I took the antiderivative of it, this is going to be x plus x squared over 2 plus x cubed over 3 and so on and so forth. That's what I have, right? So what will n have to equal to generate my first one? This is going to be x to the first power. So that means that n has to be 0 to infinity. And this is equal to natural log of 1 minus x. like so.